So when you plug those into the calculator, for 10,000 units, you're going to get 6.180. And then when you plug in for 15,000, you're going to get about 9.795. So that's how long it would take, months, to reach each of those goals. So how long did it take to go from one goal to the other? You just subtract them. You subtract those and you get roughly 3.615 months. So a little over 3.5 months it would take to go from 10,000 units to 15,000 units. Okay.
No.
All right. Okay, so we're not going to do all of the rest of the problems. We're just going to do a few. I want to jump ahead. So the numbering's kind of off afterwards. The next one should be 5, but it says 4. And then the next one should be 6, it says 5. So just bear with me there. So we're going to skip the next page. We'll come back to it. But right now, I want to do number 7 on the next page, the one that says in a certain culture. This one's a little different because it's asking you to figure out present value. They've always given us present value. They've always said, this is how much you start with. This one, they don't. Okay, so it's a little different than the ones we've started with, we did yesterday, and the one we just finished. Okay, they've asked us for time. They've asked us for the total number, right? The total number. They've never asked us to figure out what did you start at. Okay, so it's a little, they've kind of turned it around a little bit. Okay, it's the same idea, but just what they've given us is different. So in a culture, certain culture where the rate of bacteria is, here we go, is proportional to the amount present, the number triples every 4 hours. Okay. At the end of 12 hours, there were 10 million bacteria. How many were initially present? So they're giving us the final number. They're saying the final number is 10,000. What would you start out with? Okay, so, well, what's independent? What's dependent? Time, right? Time in hours, right? That's independent. So T. And then what's dependent? Bacteria, kind of like the problem we did yesterday. You can call those X and Y, that's okay. But I usually label them something close to what they actually are. So lowercase t and capital B. Okay. So it's going to be dB over dt equals K times B, right? Capital B. Once we separate and solve, what are we going to end up with? What's going to be the end? Like once we kind of do this, all of this, what is it going to kind of end with? B equals capital C e to the kt. Good. And remember from yesterday, capital C is the initial amount or starting amount. Okay. Capital C is going to be that. So that's what we're looking for. We don't know what C is. Okay? We know what B is going to be at the end, 12 million or 10 million. But we don't know what C is. So let's start. Let's start. We have a T and we have a B. Okay, so what do we know? What do we know that we can put in our table? Okay, so at 12 hours, it's going to be 10 million, right? What else can we put in our table? What else do we know? The number triples in 4 hours, right? So in 4 hours, it's going to triple to 36 and so on and so forth, right? Wait, no, the other way around. Sorry. In 4 hours, it's going to triple, right? So 16 is going to be 20, and 20, it's going to be 40, and so on and so forth, right?
Triples?
Does it say triples?
Yeah.
Oh, triple, sorry. 30. And then in 20, it's going to be 90 million, and so on and so forth. That's usually where our question is. Our question's usually down here somewhere. But this question is opposite because we don't have this. I need to figure out what this is going to be when. Zero, right? Initial, right? That's what initial means. Initial means 0, so I need to figure out, I know time is going to be 0. So if I plug in 0 for t, what is b going to mean? That's what I want to do. Okay, so let's go back to what we have so far. If t is 0, I know t is going to be 0. I need to know what b is going to be. Or do I know what b is going to be at that time? No, that's the thing. If I knew that, boom, plug it in, you're done. So we're going to have to kind of tweak this a little bit. Okay? It triples every four, right? Every 4 hours. Yeah. So we don't know what B is at the time of start, but we've called it C, right? We've called it C, so let's continue calling it C. And then in 4 hours, it's going to triple. So how much am I going to have? 3C, right? 8. And then in 8 hours, how much am I going to have? 9C. So we got something going on, right? We have at least a pattern or a relationship somehow, okay? So what we're going to do is, we've always used one of the table, right, to make our function, to make our formula, function, model, whatever you want to call it, right? We're going to do the same thing. It's going to look a little different because we're missing 2 sides. I'm missing some things, okay? I'm not going to plug in 0 for t because I know I'm already going to get B, or sorry, C. So I'm going to plug in the next one. See if this works. Okay. So it would be 3C equals capital C, right? Times e to the 4k. Okay. Next thing we did was we solved, right? We tried to solve for k. So what would I do first? If I'm trying to solve for k, what would I do first? What did you do first on the previous? Divide the starting amount, right? We don't know the starting amount, but that was our first step, so let's do it. This is 1, right? And what is 3c divided by c? 3. So no more c's. They turned into 1s. That's good. So now I only have one thing left to solve for, right? So what is it going to read next? If I want to get k on the ground, what is it going to read? Natural log of 3 equals, keep going, 4k. That looks familiar, right? Divide both sides by 4. You get k equals 1/4 natural log of 3. We still don't know what c is, but at least we know what k is now. How's that going to help us? Yeah, there you go, right? Now we can plug in some more stuff. As we're getting more useful data, if you want to call it, or more useful information, we're starting to build it, right? So that it's helping me get to C. So let's see what we have so far. We got B equals C to the E 1/4 times the natural log of 3 times t. Now we're trying to solve for c. If I know what t is and I know what b is, because those are the only other variables are t and b. And like you guys just said, I have a bunch of answers already. At hour 12, there should be 10 million. At hour 16, there should be 30 million. At hour 20, there should be 90 million, right? So now you can go back and figure out what those are going to be. So you can use any of those that you want. Doesn't matter which one you use. You can use the first one, second one, or third one, as long as it's correct. Okay. So then we go 10 equals, don't know c, e to the 1/4 times natural log of 3 times 12. Okay. Oops. Okay. We're not going to divide both sides by c right now. I'm going to divide both sides by e because I know everything there. There's no variables here. The only variable is c. So once you do that, you're going to get c. So I go to my calculator. And we're going to plug in that answer, but we're also going to kind of do a common sense, make sure it makes sense in terms of everything. So 10 divided by e to the 1/4 times natural log of 3 times 12. So I get a decimal. 0.037037, looks like a repeating decimal maybe. Okay? That's not what you guys got? Did I do something wrong?
Well, I put 10 million.
Yeah, I said 10 million.
Oh, yeah. That was my next question. Yeah, that was my next question. Does that number make sense? It's a decimal. But it's not really a decimal, right? Because it's millions. So it's really 370,000, right? That was my next question. Does that make sense in terms of a problem? Should I have about 370, let's see, so 370, it just repeats, right? Yeah, 370. Does that make sense? Does that number make sense in our list? It does. It fits, right? Because it grows by multiples of 3 every time.
Yeah.
That is how it works. But we're using calculus.
Oh, okay.
Yeah, this problem you could have done without calculus. You could have gone backwards and backwards engineer it. You could have done it. Yeah, you could have done it. Sometimes you can. And when you can, do it. Okay? I used calculus just to show you can use calculus, but sometimes some of these problems, especially the exponentials, because they're exponentials. You guys have been doing that since Math 1. Do it the way you want to. Okay? So I'm just showing you, like I said, I'm just showing you the calculus way to do it, but let's see, bacteria. But by no means is this the only way. Yeah, you could have backwards mapped it, right, by dividing. Gone up the list, divide by 3, subtract 4, and you could have gotten that. Okay. Let's see what time we got. Okay, so what I want you to do now is I want you to, let's go back. So we're not going to do, so if you look at the next question, do you guys have a question after this?
Yeah.
It's the same question as, I don't know why it duplicated, but it's the same question as number 1, yeah, or 2. It's the same question as number 2. I don't know why I duplicated, but.
Hey, wait a minute.
So yeah, didn't need that. All right, so what I want you to do is I want you to do 5, the one that says 4, but it's supposed to be 5, and the one that says 5, and it's supposed to be 6. I want you to do those two right now.
You did it to start with 6, 7, 8.
Okay.
Okay. Luckily, I already did most of the formula.